An example of a linear equation would be two x plus 6 equals 18. This isn't a one-step equation, but it's an easy two-step equation. Okay, so, well, what do? What's the first thing you'd want to do with this equation?
Subtract.
Subtract 6 from both sides, right? Okay. So you're going to do now, having written that, I can say you could also divide everything on both sides by 2, but don't want to do that at this point, okay? Because you've got to use a distributive law when you do that. I don't get to the distributive law yet. Okay, so we'll get to the distributive law in just a minute. And that gives you 2x equals 12. Then you do 2x over 2 equals 12 over 2, dividing both sides by 2. And a couple of dots because there's some explanation involved, but you get x equals 6. Okay, then you really want to check. When you solve an equation, you want to check your solution, because that gives you immediate feedback if your solution doesn't check it. Because you get immediate feedback if you've done it wrong. If the check doesn't work out, then you know you screwed it up. And you don't have to wait for the open math to tell you you're wrong and penalize you a little bit, okay? Or on a test. You know, you don't have anybody tell you whether it's right or wrong. You better check. I don't put time limits on tests, so you have time. Okay? Well, you check by taking x equals 6 and plugging it in here, which gives you 2 times 6 plus 6 equals 18. And of course, that's 12 plus 6 equals 18. So that 18 equals 18. Okay? Okay. Okay, what are you going to do with this one? Well, I would recommend that you use the distributive law. 3 times quantity x plus 4 is three times x plus 3 times 4. And of course, if you've done algebra recently, you just say, well, that's 3x plus 12, but I'm going to write it out, and I want you to write it out for now. Okay? Just to make sure nobody gets off on the wrong foot here. Well, then that's 3x plus 12 plus 5 equals 7. I recommend that when you're first doing this, you don't skip steps. Just write it out. Doesn't take long to write out. It's kind of automatic if you know how to do it. And if you don't know how to do it, you need to get in the right habits. Okay? So you got 3x plus 17 equals 17. Now you can say 3x plus 17. And if you're going to subtract the 17. Okay? So now you have 3x equals negative 10. I did skip a step there. It'd be 3x plus 0 equals 10. And then 3x equals 10. So, you know, if you want to skip that step, I won't yell about it too much. It wouldn't be a bad idea to put it in there. So now you say, okay, 3x over 3 equals negative 10 over 3. And you really don't want to write all the factoring and stuff like I did earlier. So you write a couple of ellipses here. And you see that then x equals negative 10 thirds. Then you check that. Well, about out of time, so I'm gonna take the time to check it. Okay, one more though.
Okay, so you divide, like, number, the amount of people that, amount of people. Yeah, you don't do it.
Okay.
I was so tired after doing the math.
Now, since we did a review of fractions, you're gonna wanna maybe do a common denominator here. People will often wanna do that. It's totally unnecessary. But you can say, the common denominator is 12. Okay? So if I multiply both sides by 12, I'm going to get rid of all fractions. Okay? It's much easier to deal with these if you don't have to deal with fractions. You don't have to worry about common denominators. You just, putting everything over common denominator, just multiply by the common denominator, and that clears out all your fractions. So we can say that 12 times x over 3 plus 5 fourths equals 12 times 7. And that, of course, is 12 times x over 3 plus 12 times 5 over 4 equals 84. Well, we're a minute over time, so I'm not going to do all the details and why, but 12 times x over 3, 3 goes into 12 4 times, you get 4x. 4 goes into 12 3 times, so that's going to be 3 times 5. Okay? Now the point is, then, that once you've done this, you don't have fractions anymore. That's cause for great joy. It's much easier than trying to put everything over a common denominator, because the denominators are going to go away anyway by the time you're done. Okay, so now we have 4x plus 15 equals 84. Subtract 15 from both sides, you get 4x equals 69. And then divide both sides by 4. And x is 69 fourths. And you have the option, if it's useful to you, if you've got a graph value of x, you then want to do that as a mixed number so you know where to put it in the graph. Otherwise, improper fractions are just, okay? Okay.